All right, so page 15, number 1. It says at the top that we're going to use the following balanced chemical equation for the following two problems. We're going to do numbers 1 and 2. Everybody understand that? These were already assigned to you, but I've noticed when people come for help that they were blank. People are not going through the work here, so I figured I'd show you these. The key is up on the canvas, so you can check your answers if you did do this. But the biggest thing people are asking about is how do I map this? So what you're going to do is you're going to start with what are they asking for? So I underline what they're asking for. They're asking for how many moles of nitrogen. So that's where I'm going to end. Then I ask what do they give me? And they're giving me 9 moles of oxygen. So that's where we're starting. So when we're mapping, what we're mapping is where on this Stoich map are we going? We're starting with 9 moles of oxygen. So I know how much oxygen I have, so oxygen is my known substance. I don't know how many moles of nitrogen I have, so that is my unknown substance. So I'm going from moles to moles. This is just a one-step equation. But like everything else, I would like to see unit and substance. So this is going to be from mole of oxygen to mole of nitrogen. Does that make sense, everybody? Since this is one step, we're only calculating the mole of oxygen to the mole of nitrogen. So I'm starting with X mole of nitrogen over my 9 moles of oxygen. And this is equal to, at this point, since I'm going from moles to moles, I'm using the coefficients ratio right now. That's what it takes to go from the known to your unknown. So my coefficient of unknown is my nitrogen, which is 2. So 2 mole of nitrogen over my known value is oxygen. So that's going to be 3. So 3 mole of oxygen. 9 times 2 is 18 divided by 3 is what? X equals 6 mole of nitrogen. That's all that's required. This problem only required us to take one step, going from moles of oxygen into moles of nitrogen. We found it just with that one step. But not all of them are going to be one steps. When you go to number two, they're asking us how many grams of water are made when 2 moles of ammonia react. Does the excess oxygen matter at all? No. There's not a value given, and they're not asking anything about oxygen. So excess means nothing. I don't care about it. Okay? The only time I care about excess is when they're asking which one is excess and how much excess is left over. And that will only be found through a BCA chart. It will not be found doing this. So we understand that. So we're starting with moles of ammonia. Okay? The only place I can go for moles of ammonia is go across to my other substance. So now I'm going to go to my moles of water. So now I would be here, and they want to end up in grams of water. So I then have to do grams of water. So there are 2 arrows on our map, which should tell me that I'm doing 2 steps. The first step involves the first 2 parts of this map. So I'm going to go from mole of NH3 to mole of water. So X mole of H2O. Notice the one on the right is always the X. So that's going on top. Over, I have 2 moles of ammonia. This will be equal to, now we're looking at our coefficients. Coefficients for water is 6. The coefficient for ammonia is 4. So this will be 6 mole of water over 4 mole of NH3. 2 times 6 is 12, divided by 4 is what? This is 3. So at this point, I've crossed this one off. I'm done with the first step. Okay? Since I'm done with the first step, I now go, I'm here, I'm going to go to the next step, which is going to grams. So I'm going to say mole of water to grams of water. Everybody with me so far? So the one on the right is grams, so X grams of water over my 3 mole of water. That's what we just found that we had here, right? Still the same problem, we're just in a new step. The molar mass of water would be 16 for the one oxygen and then 1.01 for each hydrogen, so that becomes 18.02 grams of water for every 1 mole. 3 times 18.02 is what? So we're going to have a 6, 0, 6, 3. So 36.06 grams of H2O. And that is our final answer for that one.